Hello everyone, welcome to another YouTube channel. In today's lecture we are going to study about optical instruments. So as you can see, the first optical instrument that we are going to study is simple microscope. So a simple microscope is basically an instrument which is used to magnify the small objects. To get the better and large view, we use this simple microscope. So it is used by watchmakers, jewelers to have magnified view of tiny components of watches and fine work on jewelry. It is also used to examine fingerprints and palm lines and by the students to read vernier scales. So as you can see, there are many daily life applications of this simple microscope. So let us see how this simple microscope work. So as you can see, we have taken a convex lens L, and through this convex lens we are putting our eye on one side, which is earlier next instrument will be known as eyepiece, and where the object is placed is A dash B dash, and at A dash B dash we are going to place the object for which we want the magnified view. Okay, so here A dash B dash and here is our eyepiece. So this will be eyepiece side and this will be objective. Since simple microscope is basically a lens like this, so this part which you hold here in hand, and here you will get the magnified view. So in this simple instrument, simply object AB is placed such that it is lying between the optical center and focus of the lens. So when you place the object very near, when you place the lens very near to the object, you will get a magnified view, that's A dash B dash. And to get a clear view, we have to put our eye at the least distance of distinct vision, which is 25 centimeter for a normal eye. Okay, so this is how the simple microscope work. Okay, now let us see what are the formula involved in calculating the magnifying power of simple microscope. So to calculate the magnifying power, we have to use two angles. First one is angle separated by the image at the eye, which you can see easily here is beta, and second angle which we are going to use is angle separated by the object when it is placed at the least distance of distinct vision. So that angle will be alpha. So from that angle, if we calculate beta and alpha, so since alpha and beta are very small, we can take beta as tan beta and alpha as tan alpha. So in this triangle, if you see, beta is AB upon OA and alpha equals to tan alpha is equal to AB by D, that is perpendicular by hypotenuse. Okay, so after putting these two values, you will see AB will get cancelled and M will become equal to D by OA. Okay, and since OA is the object distance, we can replace it by U. So M formula will become capital D upon small u. We can also replace this formula using by lens formula. So in lens formula, what we see, 1 by V minus 1 by U is equal to 1 by F. Here V is equal to minus D and U is equal to minus V with sign convention. So when you put this value in the lens formula, you will get 1 by U is equal to 1 by D plus 1 by F. Since we required M as D by U, so we have to multiply both sides by D, and after multiplying it, you will get D by U as 1 plus D by F. So there is another formula for magnifying power of simple microscope, that is M is equal to 1 plus D by F, and one more formula which we saw earlier is D by U. So both formula can be used for the solving of numerical problem as per the requirement. Here are some simple uses given by the simple microscope, which I already told you. Let us move to compound microscope. So compound microscope is basically an complex version of simple microscope. So compound microscope is used to see further tiny objects like biological specimens. If you are using onion peel to see its cell and nucleus, cytoplasm, like that. Okay, So there are two lenses used in compound microscope, one is objective and another is eyepiece. Okay, so how does it work? First you have to place object AB in such a way that it lies beyond focus of objective. Okay, and when it is placed in such a way that then its image will form on the other side of the objective lens beyond f0. Okay, that is focus of objective, and it will be magnified, and in that image will be that image A dash B dash will act as uh, object for eyepiece, and you have to keep objective and eyepiece lens in such a way that the first image A dash B dash should form in a such a way that it should lie within the focal length of eyepiece. So you can see easily here A dash B dash is lying between E and F E dash. So if you draw the final image using A dash B dash as object, you will get the image here as A double dash B double dash. So now the ray diagram here is completed. All the symbol, that is U0 is object distance with respect to objective, V0 image distance with respect to objective, UE is object distance with respect to eyepiece, and D is image distance with respect to eyepiece. Now using all the triangles, if we calculate magnifying power, keeping in mind that alpha and beta are very small, we can take alpha and beta is equal to 10 alpha and 10 beta respectively, and magnifying formula same as earlier we have calculated, angle separated by the image at the eye divided by angle separated by the object when it is placed at the least distance of distinct vision. So you will get finally, keeping all the symbols, you will get M is equal to A double dash B double dash divided by A dash B dash into A dash B dash by AB. Here you can see A double dash B double dash upon A dash B dash is ME, linear magnification by eyepiece, and A dash B dash upon AB is equal to M0, that is linear magnification by objective length. So completely you will get is capital M is equal to ME into M0. Now M0 we can further write as minus V0 by U0 using the ray diagram, and if we apply the lens formula also for this, you can get another value for V0 by U0 as F0 upon U0 minus F0. So you can replace M0 value by minus F0 upon U0 minus F0. Similarly we can also write VE upon UE in place of ME, or D upon UE. So keeping both the values of M0 ME in capital M, we will get finally capital M as V0 upon U0 into D by U with minus sign, and the other value will be minus F0 upon U0 minus F0 into D by U. Okay. So this is how the compound microscope magnifying formula you can get, and the ray diagram has already I explained you. You can see it here again. Okay. So if you want to draw, I can zoom it for you. You can pause the video to draw it. Let us move to another optical instrument, which is astronomical telescope. So what are the applications of astronomical telescope? Since above two instruments are used to see the magnified view of an object which is placed near the objective. So what happens if object is not near to the objective? So first you have to take the image of the object near to the objective and then magnify it. So for viewing celestial objects like moon, stars, planets, okay, other galaxies, we use astronomical telescope, and there are of two types, one is refractive and one is reflecting. So first we are going to see the refracting telescope. So here you can see an object AB which is kept at infinity. So all the rays which will come to the objective lens will be in the form of parallel rays. So let us say that this ray make an angle of alpha with respect to optical center of the objective. Now whenever the object is placed at infinity with respect to objective, its image will form exactly at the focus of, or at the focal length of object. So you can see A dash B dash is forming at f0. Now you have to keep eyepiece in such that this image A dash B dash form within the focal length of eyepiece. Okay, so you will get the final image A double dash B double dash between O and Fe dash. Okay, keeping all the notations in mind, we can again calculate the magnifying power of this astronomical telescope using m is equal to beta upon alpha. Since again alpha and beta are very small angles, we can replace it by tan alpha and tan beta. So m becomes finally OA dash upon EA dash. Keeping the value of OA dash as plus f naught and EA dash as minus u with proper sign convention, you will get m as minus f naught upon UE for astronomical telescope. When the final image is formed in the least distance of distinct vision, you can use another formula for magnifying power by using eyepiece lens formula. So here if we use lens formula for eyepiece and using all the notations and proper sign convention, you can get f naught upon UE as minus f naught by Fe into 1 plus Fe by d. Okay, now let us see the last optical instrument or the last part of this video, which is reflecting telescope. It is a very common telescope and is the most useful telescope because the image formed in this telescope will be much clearer and distinct compared to refracting telescope. Okay, so let us see the working of this telescope. In reflecting telescope, the objective will be a kind of convex mirror, okay, sorry, a concave mirror. So a concave mirror is M1 and the image of AB will be formed first with respect to objective, and that's the light ray will be transferred to the eyepiece lens using another plane mirror M2. Okay, so you can see the image is first forming with respect to M2 as A double dash B double dash, and then image are formed with respect to eyepiece as A dash B dash. Now using this ray diagram and all the notations and symbols, we can calculate the magnifying power for reflecting telescope as beta upon alpha, and since again angle alpha and beta are very small, we can replace it by tan alpha upon tan beta, and here we get very simple value of m as m minus f naught upon Fe, where f naught is focal length of concave mirror and Fe is focal length of eyepiece. Okay, so in this lecture try to explain all the important optical instruments: the simple microscope, compound microscope, astronomical telescope of refracting type, and astronomical telescope of refracting type. Okay, thank you for watching this video and have a nice day.